See, the topic for this week for us is actually calculation of torque, static rotational equilibrium of rigid bodies, toppling, kinematics of rotation of a rigid body about a fixed axis of rotation. That is what we talk. So it is like a brush-up topic. So that is the reason why what I was just checking is the theory which already taught last year is just sufficient for us. But whereas the numericals, I have prepared a fresh content. This I will post you. Even toppling also, I didn't given you notes because I didn't find time yesterday. I have spent total time for the first part. Toppling, I will again give another notes. Maybe Thursday I will give you. Right. Okay. Before we go with, I'm just brushing up of what I taught you during the circular motion chapter. In a circular motion chapter, majorly you dealt with a point mass, something which is rotating in a circular path. Now here it is a rigid body of different shape. So this is a rigid body. Are some arbitrary shape. You may don't ask me what is the shape. Some arbitrary shape, but axis of rotation is fixed. It is rotating. Now I have marked a point A on the rigid body. Now, in the course of rotation, A will describe a circular arc with respect to a point on the axis. You can call that as a center for that arc. And this subtends an angle theta. You call this small value of theta as angular displacement. And you know how to give the direction. It is given by right hand grip rule. For small angular velocity only, it is a vector quantity. Small angular displacements are vector quantities. Large angles are not vector quantities. Small theta is a vector quantity. Large angles are not vector quantities. Right. Now you see here, angular velocity is defined as the time rate of change of angular displacement. Fixed axis system, you see right hand, 4 fingers. You can see my hand right now. You can see my hand right now. This right hand, 4 fingers, if they are showing the turn factor, then the thumb represents the angular velocity. So that is what right hand thumb rule represents. That's what I have written here. Right hand, 4 fingers, if curled along the direction of the turn, thumb represents the direction of omega bar. So what just I'm not teaching again, I'm just highlighting this again. V bar, angular velocity, linear velocity and angular velocity are related as V bar is equal to omega bar cross R bar. This is one relation. All these things we have already done in circular motion chapter very recently. Similarly, you want omega bar. This is another way. Omega bar is equal to R bar cross V bar by R square. Remember, these are allowed only for a fixed axis system. Right. Next. Okay. Next, angular acceleration. This is called angular acceleration. So what is angular acceleration? It is defined as the time rate of change of angular velocity. Here, omega bar, alpha bar, if they are in the same direction, like linear velocity and linear acceleration, same direction, speed increases. Similarly, here, magnitude of omega bar increases with time. Similarly, if omega bar and alpha bar are in opposite direction, omega bar decreases with time. Remember, in rotational motion, about the fixed axis, this is also important. About the fixed axis, theta, omega, alpha is common for every particle. Remember, this is about fixed axis only, right? Now, all these things you already know. In circular motion chapter, we have dealt. Right. Now, give me confirmation. What about you here at Tarnaka students? Have you followed? Very clear? Right. ECL students, give me your confirmation.
Sir.
Have you followed?
Sir.
Right. Fine. Nana, I forgot your name. What is your name?
Sir, Dakshish.
Yamana?
Dakshish.
Akshish. Right. Now you see a simple case here. Now imagine that you have a situation like this here. This is some rod. And this rod is in a slanting position with one end touching the floor and the other end touching the wall. The end A touching the floor, the end B touching the wall. The end A is having velocity VA and the end B is having velocity VB. Till this point, do you have any doubt? And there is some angle theta here. At that instant, the angle is theta. Dakshes. Thank you, Dakshes. Right. Now this theta is the angle at that instant. This is VB and this is VA. Right. Now, if you do geometry, Are bhaiya, this is of length L. This is of length L. And this will become L sin theta. This will become L cos theta. Right. Now, try to please understand this is actually not a fixed axis system. This is not a fixed axis system. Right. Such systems will be operated as instantaneous axis of rotation. If it is not a fixed axis system, you will operate that in terms of the instantaneous axis of rotation. You may ask me now how to find the instantaneous axis of rotation. Via this is VA, and I will draw a line perpendicular to this velocity direction. Similarly, at that instant, this is velocity VB. I will draw a perpendicular. These two perpendiculars meet only at their center of rotation, and that is at that instant. Remember, the next instant, B is not here, A is not here. Therefore, only at that instant, about this point, the entire rod is rotating. And about this point, it is a pure rotation. Such a point is called instantaneous axis of rotation. By the way, this is VB and this is VA. And the component in this direction is a VB cos theta. And if this is a theta, this is a 90 minus a theta. And this is a 90 minus a theta. This is a VA. This is a VA sin theta. So VB cos theta, VA sin theta. VB cos theta, VA sin theta. So what is happening? Along this line, relative velocity of separation becomes 0 because it is a rigid rod. So therefore, see, since the length of the rod along the length is constant. Length is constant. See, along the length of the rod, you can see that VA sin theta is equal to VB cos theta. Equation 1. Next, omega. Omega again refers to what? Already in circular motion, I taught perpendicular velocity, perpendicular component of the velocity by length of the rod. So here two aspects are there. One, about this point, this is VA, and this distance is L cos theta. So omega can be written as VA by L cos theta or VB by L sin theta. So all these things you already know in circular motion, but I'm just brushing up. So what is that you need to know? If suppose if you select some point B, for example, if I am here, for me, what is the perpendicular component? VA cos theta plus VB sin theta. This is the V perpendicular component. And this is about B by length. Arya, you can use this, you can use this, or even you can use this. Sir, I won't believe. No issues. VB, I have the relation VA sin theta is VB cos theta. So in the place of VB, you use VA sin theta by cos theta. You will get VA sin square theta by cos theta. So now you operate, you will get VA by L cos theta, which is same here. Right? So basic kinematics terms. So same thing I have given. Otherwise, sometimes what will happen? Sir, I have a rod like kind of arrangement like this. Okay. At this instant, the velocity of A is VA. That instant, velocity of B is VB. Right. Good question. I can find angular velocity like this. Angular velocity can be find out like this. Very simple. You said that this angle is 30 degrees. This angle is 60. They are given the data actually. Right. No issues. What is going to be the angular velocity of the rod? Good question. I can do it in two different ways. This is basically a triangle. I have this rule, sine rule. Agreed? You know the sine rule. So A by sine 60, B by sine 30, L by sine 90. So I have the relation for A as well as B, right? Remember, this is the instantaneous axis of rotation. You may ask me how to find instantaneous axis of rotation. Just now I told you. But yeah, this is the velocity vector, and I have drawn a line perpendicular to that. This is the velocity vector. I have drawn a line perpendicular to that. The point of intersection gives what? At that instant, axis of rotation. That is the reason why it is called instantaneous axis of rotation. So about this point, VB by B. Yes, correct. VA by L. 1 minute. VA by A. That is also okay. Choice is yours. So what was my intention of discussing two such situations? In a rotational motion case, if you want to find IA over, this is the technique. Because they won't give you omega straight away. But frankly speaking, the entire chapter, I won't use omega term at all. I won't use omega term at all, totally. But you need to know this because they will ask questions because the syllabus contains kinematics of circular motion. Right. Next. What happened to this? I'll discuss this question later. Now you have a situation. See and try to solve this. This is a question. You have a rod-like kind of arrangement here. At this instant, what I know is the velocity V here. And this makes an angle beta here. And this makes an angle alpha here. So what I want is omega. 1 omega straight away you can say V by A. That is for sure. but I haven't given you anything about A. I haven't given anything about A. The data available to you is only three terms: alpha, beta, V. You want to answer anything, you answer in these three terms. No issues. Now I'll take this triangle. I'll take this triangle. In this triangle, since to find IAOR, the only technique I know is I'll draw a right angle to that velocity and a right angle to this velocity, and this point of intersection gives IAOR. Agreed? Everyone in this class, right? Next point is, now the next point is, if this is beta, this is 90 minus beta, this is alpha, this is 90 minus alpha, right? In the triangle, A by sin 90 minus beta is B by sin 90 minus alpha is, okay, Abhaya, this is 90 minus beta, this is 90 minus alpha. Can you please tell me what is the angle here? The angle here is alpha plus beta. So therefore, that is L by sin alpha plus beta. So wherever I have L, I can write this. Right. You said V by A. V already given. A I will substitute this. Done. Okay. Tarnaka students, do you have any doubt? Right. ECL students.
Yes, sir.
That says, any doubt?
No, sir. No doubts.
Right. I think these things you can manage it. Not required at all, totally. Okay, no other, why should we compromise? Just to go through this case, this will be the last case in the basics. This will be the last case in the basics. Now you have a situation like this. A rod AB is given, and the center of mass of the rod otherwise is moving with velocity V at that instant, making an angle 30 degrees with the horizontal. And it is in which direction? Clockwise, but anti-clockwise sense rotation. So, okay, fine. I took this as a horizontal, and this is x-axis, and this is y-axis. Right. Now let us study A, what is happening. A, only translational motion if you consider, this is the picture. Please confirm whether you understood or not. Forget about rotation. When I said VCM means there is only translational part, which means A will have V velocity, you consider only translational. With respect to the center, this will have L by 2 omega. Okay, Bhaiya, this is 30 degrees. So this is 60 degrees. Why? Because if this is a 30, this is also 30 degrees. So to make 90 degrees, you require 60 degrees. A. Now, can you please give me the total velocity of A? The total velocity of A at that point is due to the translational part plus the rotational part. So therefore, V, what is the components if you resolve? You will have this one as L by 2 omega cos 60. And this is L by 2 omega sin 60. Okay. What do you want? V minus L by 2 omega cos 60 I cap. That is the x component. L by 2 omega sin 60 j cap is the z component. Now, have you understood how I have derived the velocity of A? Anyone in the class? No. ECL students. Dakshesh.
Yes, sir.
Are we clear?
Yes, sir.
Right. Now take up B. B. B will also have translational velocity V. Bhaiya, see, this is V. Every point will have the same translational velocity V. But rotation point of view with respect to center of mass, this is how it will have L by 2 omega term. Okay, that makes an angle 60 degrees in this direction. Accordingly, I have resolved. Accordingly, I have resolved. Are we clear? So, just please confirm. See, 3 different ways of asking omega. I have given you that. All these 3 things comes under kinematics of circular motion. Please confirm whether you understood this or not.
Yes, sir, understood.
Right. And one more question we need to do actually. And this question is from Pathfinder actually. Their question was not clear, so I am just everyone try to please go through the question carefully. You can see an object is rotating at an angular velocity omega. It is a very standard question. If not now, someday you will get this question. Angular velocity omega naught about an axis that passes from the origin and is directed in the XY plane. You can see XY plane is also mentioned here. XY plane. And 45 degrees is what you mentioned. 45 degrees, right? What is the velocity of a point on the body located on the positive z-axis? Frankly speaking, somewhere here at a distance z from the origin. Right. See, honestly speaking, let me see how good I am in drawing this. This is your omega naught term. Let me see honestly how good I draw this. You should imagine this in a 3D sense. Okay. So I have tried my level best to make it 3D here. Now here lies the point which is at a distance Z. That's the problem. Okay? Right. No issues. By the way, you said this is the direction of omega bar. So omega bar can be given as a unit omega naught times a unit vector in that direction. Minus cos 45 I cap plus sin 45 j cap. So obviously this will become omega naught by root 2 times minus I cap plus j cap. Till this point, any doubt? Omega bar. Okay, fine. What do you want? You want the linear velocity which is at a location. Okay, fine. R bar is zk cap. What is the relation between linear velocity and angular velocity? V bar is omega bar cross R bar. That's the deal. So you take the cross product, you will get this as your answer. Just some basic model I taught you. Any doubt? ECL students? That says, any doubt?
No, sir.
Right. Yes. So now the actual theory starts. The entire weak theory, as per my knowledge, if you allow me, only one page. This is my guts. Only one page. But don't expect that problems are one page. Problems are unlimited. And I did not added Pathfinder questions in that. I did not added toppling case in that. Right. In fact, Pathfinder questions also I did not add it in that. Right. Yes. Now let us study what torque is. If you can imagine an axis of rotation like this, imagine that this is a door for you. You have n number of options to turn the door. You can apply force here. You can apply force here. You can apply force here, but not normal. This makes some angle with the normal. And you can apply even force like this. Right. Okay. In this, this is a 3D picture. And if I am seeing this from the top view, this is a fixed axis. And the forces applied are like this: F0, F1, F2. If required, we will add F3 and F4. Can I ask you a question? Will F0 and F4 helps us to turn the door? No, they can't produce any turning effect. Right. Of course, F1, F2, F3 will definitely help in turning the door. I'm not speaking any physics right now, just logic sense. But out of F1, F3, F2, if they are of same magnitude, out of F1, F2, F3, F3 will have greater ability than F1 and F2. So therefore, in turning this door, my observations are 3 factors are affecting the turning ability of the force, or the turning effect of force. The turning effect of force. What are they? Number 1, the point where the force is exerted. Number 2, the magnitude of force. Number 3, the direction in which the force is exerted. So to sum it all, imagine that I am using a wrench-like kind of arrangement to turn a bolt. This is a fixed axis system. I am applying some force F like this. Okay. So therefore, the torque of the force, also called as a moment of force, also called as the turning effect of the force about O, this point, is defined as R bar cross F bar. I am repeating, the turning effect of the force or the moment of force or the turning effect of the force about the point O is defined as R bar cross F bar. So whenever you face such situation, such challenge, very simple. Remember, the axis of rotation is into the plane of the board right now. And this is the line of action of force. And on the line of action of force, you are drawing a perpendicular. This perpendicular is called force arm. This perpendicular distance is called force arm. Force into force arm is actually called as moment of force. I repeat, force and perpendicular distance, force arm, is called moment of force. or this is also called as turning effect of the force about the point O. Got the point? Now, do you have any doubt? I taught you in a very elemental, fundamental level. Till this point, do you have any doubt? Whenever you need to find torque, first identify what is the force. Second, identify through which point the force is acting. Third, identify the axis of rotation. Fourth, draw the line of action of force. Fourth, draw a perpendicular on the line of action of force from the axis. And that distance is called force arm. So finally, what is the torque? Force into force arm. Now you see, you can give the direction with right hand rule. If you align force arm along the four fingers of your right hand and turn the four fingers of the right hand along the direction of force, thumbs gives you the direction of torque, or R bar cross F bar gives you the direction of torque. I repeat, now force arm is along OA. I set my four fingers of right hand along OA and I am turning them along the direction of action of force. Now thumb represents the direction of force. In this case, torque is towards me, which means if you see what is that you are seeing as a board, towards you, outward, the torque is outward, means in this case, it is in the Z direction, positive Z direction, provided if this is X and this is Y. Right. Dharnaka students, first point, do you have any doubt on this? Sure. Dakshish, any doubt till this point? This is the very fundamental of my teaching for the entire week. Now, if you compromise here, you will not follow anything thereafter. Now, tell me any doubt on this.
No, sir.
Now, remember, when you are defining torque, you should define the torque either about a point or about an axis. You cannot define, when I am asking you torque, you should ask me about which point. Right. Force in translational motion is analogous to torque in rotational motion. Force causes rate of change of linear momentum. Torque causes rate of change of angular momentum, which I will define some 2 weeks down the line. If you are not applying any force, say if the body is at rest, it will remain at rest. If you apply force, it gets acceleration. If you apply torque, it gets angular acceleration, which we will deal next week. This week, we will deal only about torque. Right. Now, you take a situation like this. It's a rigid body. And there is a point O here. Remember, this is a fixed axis system. Some point P, some force F bar is acting. I choose that O to P is R bar term and this is F bar term. The line of action of force should not intercept the axis of rotation any point of time. If line of action of force intercept axis of rotation, you will not have any turning effect. For example, you see this force have no turning effect because of two reasons. One, there is no force arm. Two, it is intercepting the axis of rotation. Two, you see, in this case also, this force which you are applying is intercepting axis of rotation. So therefore, this force did not produce any torque. So here also, the line of action of force should not intercept the axis of rotation. If it happens, what happens? Force arm is zero. So no turning effect. Next. Another important point. Force or line of action of force is parallel to the fixed axis of rotation. If it is parallel to the fixed axis of rotation, in this case, if force or line of action of force is parallel to the fixed axis of rotation, in this case, the component of the torque along the axis is zero. I'll explain simply. Suppose you have the door like this. If I am applying another force, say like this, some F5. Now this force, line of action of force, line of action is parallel to the axis of rotation. Frankly speaking, suppose if this is the point where you are applying, okay, so what? Bhaiya, this is R bar. Okay, this is F bar. Now tell me what is the direction of R bar cross F bar? R bar cross F bar is strictly perpendicular to the axis of rotation. Yes or no? R bar is in this direction. F bar is in this direction. R bar cross F bar ఎలా ఉంటుంది? Perpendicular to the axis of a quantity is perpendicular to the axis. What is its component along the axis? Zero. So therefore, that is why I have represented here the component of the torque along the axis is zero. Any doubt? That is a very important term for me. 1 and 2 are very, 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 very important terms for me. Next, the third point. Now I've identified that this is my fixed axis of rotation. And I choose 2 points. One is a point O, the other is a point O dash. O dash is below O. And remember, both O and O dash are on the same axis of rotation. Same axis of rotation. Right. If you ask me about the torque about O, I'll simply write torque about O is OP bar cross F bar. Any doubt on this? It's a basic definition. If you ask me about torque about O dash, I will write O dash P bar cross F bar. But please try to understand from the geometry, from this geometry, what you can write? O dash P bar is equal to O dash O bar plus OP bar. That I have substituted here. Finally, I will get tau O dash bar is equal to O dash O bar cross F bar plus OP bar cross F bar. Remember, for a fixed axis system, this is 0. Why? Remember, component along axis is 0. Don't just see. You stretch the right hand, 4 fingers along O dash, turn along F bar. Now see what is the direction of the thumb? Perpendicular to the axis. I'm repeating again. Set your 4 fingers of right hand along O dash. Turn in the direction of F bar. F bar is into the plane of the paper. F bar. What is the direction of thumb? Perpendicular to the axis of rotation. So therefore, whether you choose about O, whether you choose about O dash, result is the same. Remember, this is true only for fixed axis of rotation. For a fixed axis of rotation, whether you choose a point at O or whether you choose a point at O dash makes no difference. Right. Yes, this is a very important point. Dakshesh, what about our students?
Yes.
Clear?
Yes, sir.
Right. These are fundamentals. Really, really very important points. Right. Now I'll take a simple example of torque right now. A very simple example. Now you see at this instant, this is a fixed axis, hinged actually. fixed axis of rotation. Right. This is the sense of rotation clockwise. And number two, what is the force that causes a torque? The force that causes a torque is the weight. I told you 2 points to apply torque. Identify first force. This is the force. Extend this. This is the line of action of force. Here is your axis of rotation. Draw a perpendicular onto this. Bhaiya, this is L by 2 because center of mass is the distance L by 2. This is theta. So this is L by 2 cos theta. And remember, this is called force arm. This is force. Force into force arm is the torque. mgL by 2 cos theta. Any doubt? Pakka? Sure? Right. Another simple case. Everyone try to go through this. I'm just dealing still fundamentals. Right. Go through the question, everyone. Everyone try to go through the question. Yes. Now, see what first identify what is the axis. They have chosen the axis as O. Till this point, I don't think you have no issues at all. Right. Good question. Now I have selected the point. Now what are the forces? That also I need to work one by one. What is the significance of F1? Anyone in the class? What is the significance of F1? It is passing through the axis of rotation. So torque due to 1 is 0. Any doubts? Paka? Right. Next. F1 is done. F2. Bhaiya, for F2, this is the line of action of the force, F2. And this is the perpendicular. You said this is a 3 meters. So this will be half of that, 3 by 2. So therefore, force arm is 3 by 2. Force is F2. 3 by 2 F2. In which sense? In this sense. Torque. Array, right hand fingers perpendicular is up. F2 is right. It turn into the plane of the paper. You will have the direction of the torque. The direction of the array, if it is a clockwise torque, into the plane of the paper. If it is an anti-clockwise torque, outward to the paper of right. Right. Now this is right. Now any doubt on tau 2? Dakshesh,
No, sir.
any doubt on tau 2?
No, sir.
Right. 3. Via 3. Oh God. Now what is a 3? That I need to work. Now I have drawn some line and this is OB, and I don't know whether it is a perpendicular or not, but they have given one thing. Theta is 37 degrees. Okay, no issues. Remember, in this is 4, this is 3. In that case, this is A, this is C, This is B. In fact, this angle is 90 degrees. And number two, one more important point is if you draw a perpendicular here, this is also 90 degrees. But you already know this angle is, this is a 4 and this is a 3. So what is this angle? This particular angle? 53 degrees. So in that case, what is going to be this angle? 37 degrees. Right. Now this is F3. And you said this is also 37 degrees. Any doubts? So now you have angle. You have angle. Actually, 4, 3, correct. They took that as 53, is not 53. Actually, this should be 37 degrees only. Why? Because I know very clearly this is 37 degrees. If this is 37 degrees, this is 37 degrees. This is 37 degrees. Now, what is that you need to draw is, you use a general formula. The general formula tau bar is R bar cross F bar. Simply, you will write as the angle between these two terms. OB into F3 into sine 2 times 37 degrees. Sine 2 times 37 degrees. So this is OB. OB क्या होता है? 5/2 होता है. Because this is totally 5. 5/2 times. What is F3? Keep that in terms of F3. F3. All are 20 newtons. 20. 2 times sine 37 cos 37. 3/5. 4/5 newtons. And the tendency is anti-clockwise. I'm just asking you again, have you understood this? Dakshesh, our
Yes, sir.
class students, have they understood my approach of determining torque of F3 about O?
Yes, sir.
Right. Done. F3. F4 also same situation. F4 also same situation. What you will do is, already this is 37 degrees and this is 90. No issues. See, about O, you resolve this into two components, forces. One force is perpendicular component. The other force is component along OE. Remember, this component will not contribute torque 0 because it is intercepting the axis of rotation. So you will have only one thing that contributes torque. So the torque of this force is OE times F4 cos theta. That's all. So I have given torques of all the four forces. What is the direction of the net torque? Or here, just add net torque, you will get minus 12. You got, see, if you get plus 12, it is in which direction? If you get plus 12, you will get this in anti-clockwise direction. If you get minus 12, కనుక్కో పర్పస్ 10:30 దా క్లాస్ This is an anti-clockwise sense. In that case, it is a plus. If it is in clockwise sense, net is clockwise sense, you will write it as a negative clockwise sense. So you add all the torques, you will get minus 12. Minus 12 means? Minus 12 means? Bolo. Clockwise. Into the plane of the paper direction. What is the torque due to all the forces about an axis passing through O that is perpendicular to the plane of the figure? Or here I have given all magnitude as well as direction. Now you ask me any doubt in this. Fundamental questions only I am dealing with. I am repeating, I am dealing fundamental questions. Boys, Dakshesh, are we clear on this question?
Yes, sir.
Right. And next question. Next question. See the next question. Dakshesh, confirm. Have you received the notes, empty notes?
Yes, sir.
Yesterday I have posted actually.
Yes, sir. We received.
Right. Chalo. See this. A cube has a side length A. 6 forces are acting on it. As shown. Each force has a magnitude equal to F. Array, 1 minute. Let me just search whether I have that. This is better now. Yeah. Now please go through the diagram. Find the torque on the cube about the side. No. If that is not mentioned, it is a very hectic problem. Whether when you are defining torque, what is the first point that you need to remember? You will define torque. You are defining torque implies you are defining about a point or about an axis. Right. Find the torque on the cube about the side AB marked as z-axis. Right. Right. Yeah, first, will F2 contribute any torque? First question. Will F2 contribute any torque? Bhavana, will F2 contribute any torque? Why? You don't like F2? Yes, F2 is intercepting AB. So F2 will not contribute any torque. Next. Will F6 contribute any torque? Why? It is a parallel to AB. So F2 gone, F2 gone, F2 gone, F6 gone. What about F5? Will F5 contribute any torque? Why? It is intercepting the axis. So because F5 is intercepting axis, F2 is intercepting axis, F6 is parallel to the axis, what happens? They will not contribute any torque. Right. Now F1. Okay. Now F1 also you can do two things. You can do two things. F1, you can do two things. One is F1 by root 2. F1 by root 2. The problem with this part is, this is again parallel to axis of rotation. This won't contribute any torque, but this will contribute torque. So what is the torque contribution of F1? The torque contribution of F1 is, remember, the torque is in which sense? Torque contribution of F1 is in clockwise sense. If only F1 acts, F1 component की वजह से the torque is in clockwise sense. So therefore, minus F1 by root 2A. Done. Yes or no? Minus sign justified or not? Why minus sign? because it is a clockwise torque. అయిపోయింది. F2. F2 will also have two components now. F2 will have one component like this, another component like this. Right. F2, no, this is F3. Again, the problem with this is F3 by root 2. This will not contribute any torque. Why? This is again parallel to the axis of rotation. So F3, this F3 by root 2 component will contribute torque. And again, unfortunately, that is also rotating the system in clockwise sense. So force it to force off. F3 by root 2 times A, and the rotation sense is again clockwise. So minus sign. Done. What else is left here? F4. F4 is the only pakka confident force, which is strictly perpendicular AD. So AD is the force arm, F4 is the force. But again, the sense of rotation of F4 is again clockwise. So minus F4 times A. Remember, this is right. This is the net torque. The net torque is negative, means the sense of rotation is clockwise and vector is into the plane of the paper. Any doubts? Am I teaching fundamentals only? Right. Dakshesh, any doubt? See, now we will deal problems related to equilibrium of rigid bodies. Actually, that is our concept. Well, let us try to understand what exactly it is. Equilibrium of rigid bodies. Till now, just prior to this chapter, we have an opinion that equilibrium means net force is zero. See, for a point mass, that is true. But for a rigid body, that is not complete statement. If I say that a body is in equilibrium, it should be totally in two equilibrium states. One, translational equilibrium. One is a translational equilibrium. This results net force is zero or acceleration is zero. Acceleration of center of mass is zero. Net force is zero or acceleration of center of mass is zero. Generally, what we will do in this process is sigma fx 0, sigma Fi 0. You will resolve forces into components along x-axis, along y-axis, and net you will equate it to 0. That is translational equilibrium condition. Second one, rotational equilibrium about a fixed axis or about a point. about a point on fixed axis. In this case, simply you will say that the net torque is 0. You will choose the point on the axis. About that point, you will say that the net torque is 0. So three conditions: sigma fx 0, sigma fy 0, sigma net torque is 0. The body may be acted upon by n number of torques, but net must be 0. If these three conditions are satisfied, you can say that it is an equilibrium. Any doubts in this? Right. We will take a simple case now. A rod AB is acted upon by three forces perpendicular to its length, as shown in the figure. In the question, it was given that the sum of forces is 0, which means we will take upward direction as positive. So therefore, F1 plus F2 minus F3 is equal to 0. That's given already. So it's already in translational equilibrium. This is already in translational equilibrium. All right. Now I'll take about A. About A, I will start. About A, I will take net torque. See, when I am taking about A, the torque of F1 is equal to 0. Yes or no? Because it is passing through the axis of rotation. So what about the torque of F3? Force into force on. It is minus F3 into A. Can someone please tell me why there is a minus term here? Because it is downwards. Right. And the torque of F2 is plus F2 times A plus B. So what is the net torque? It is nothing but minus F3A plus F2A plus F2B. Keep this aside. This is the net torque. Now I am taking about C. Remember, they have given translational equilibrium condition only, but they did not mention rotational equilibrium condition. About say torque of F3 is equal to 0. And the torque of F1 is, again, this is also in clockwise sense. And how you will write that? Minus F1A. And the torque of F2 is plus F2B, because this torque is in which sense? Anti-clockwise sense, so plus. So therefore, net torque in this case is F2B minus F1A, right? Remember, F1 can also be written as from this. F1 can also be written as F3 minus F2. F2B, F3 minus F2A. This can be written as F2B plus F2A minus F3A. Remember, this part and this part is the same. Okay, hold on. Still not at over. Still not at over. Now I'll take about B. Right. About B. About B. Net torque is 0. Next. Torque of F1 is, again, this is clockwise. But this time it is a minus F1 times A plus B. Torque of F3 is plus F3B. So net torque is minus F1 times A plus B plus F3B. Remember, I want to express only in terms of F3 and F2. I'll eliminate F1 again from here. Minus F3 minus F2 times A plus B plus F3B. Trust me, you will again get ఇక్కడ మైనస్ F3B ప్లస్ F3B పోతుంది. తర్వాత మైనస్ F3A మిగులుతోంది. మైనస్ ఆఫ్ మైనస్ ప్లస్ F2 టైమ్స్ A plus B మిగులుతుంది. Right. So same. So what I can conclude now? With this, I can conclude one theory point. Important observation. Important theory point. If a rigid body is in translational equilibrium, then torque about any point is same. If a rigid body is in translational equilibrium, then the torque about any point is the same. Whether you apply it about A or about C or about B, you got the same answer, which means torque about A is a torque about B is torque about C. This is a very important observation. Okay? So only in translational equilibrium you can apply. If it is not in translational equilibrium, you cannot apply. Any doubts? Dakshesh?
No doubt, sir.
Right. All these are fundamentals. Now your problems will start. Right. Shuru karo bhai. This is
Sir,
your first. Yes. Boys.
sir, it's break for us now, sir. Can we go?
No, can you please tell me a bit louder?
Sir, it's break for us now.
Why? It's a break for us. For you?
Yes, sir.
Why so?
Sir, we're following the Saturday's timetable.
Okay, you go ahead and whatever the balance record is there, listen it at home.
Okay, sir.
Right.
Thank you, sir.
Right. In the given figure, a man of mass 60 kg is doing push-ups. Find the normal force exerted by the floor on each hand and each foot if the man holds this position. Usually, see, it's ease in equilibrium actually. That's what is in equilibrium, right? Now tell me what will be the free body diagram of this system. If you draw the free body diagram of this system, you'll come to an idea what is happening there. So I'll draw the free body diagram here itself. Array, instead of 2, I'll take one single force. What is this called? N hands. What is this called? N foot. So he is in equilibrium, right? So sigma Fi 0. Agreed? Array, you agreed? That's no equilibrium. NF plus N hands is equal to mg. Equation 1. Next, one more important point. You can do different ways. For example, if you imagine an axis like this. Now let this be F. So net torque about F is 0. Agreed? Right. Now he is holding it like that. Therefore, see, there are two torques now. One is mg, force into force arm, and this is a clockwise, plus nh into 1.2, anti-clockwise, 0. Agreed? Boys and girls, agreed? So therefore, nh is mg times 0.8 by 1.2. 2 times, 3 times. So this is 2 mg by 3. Obviously, n foot is mg by 3. That's all. That's what you want. But this is not the answer. For each feet, per each hand, by 2 you need to do. If you pose this as your answer, that is wrong. So 2 mg by 3, how much is this? 2 by 3 times 600, 200, 400 Newton. This is also 600 by 3, 200 Newton. So per each hand, this is a 200 Newton. For each feet, 100 Newton. That's all. Any doubts? Boys and girls. Pakka. Shall we proceed for the next question? Shall. Yes. Go ahead. Start with this. అవును చేసుకోవచ్చు. But fundamental approach, I need to do it like this only. Right. Next. In the given figure, a uniform plank of length 6 meter, weight 200 Newton, rests horizontally on 2 supports with 1 meter of the plank hanging over the right support. right support. To what distance can a person who weighs 800 Newton walk on the overhanging part of the plank before it just begins to tick? Uniform plank of 6 meters and weight 600 Newtons. Clearly, total how much? 6 meters. So from here, at a distance of 2 meter, weight acts, and this is the weight of the plank, and this is the weight of the man. About this point, you want to find torques. I think that is what you want, right? Anything else? Now, therefore, W plank times 2 meter is equal to W man times X for net torque to be 0. Any doubt on this? Anika, any doubt? Right. What is the weight of the plank? 200 into 2. What is the 800 Newton into X? Therefore, X is 400 by 800. It is half a meter. Half a meter, which is equal to 0.5 meter. Here, the X term is 0.5 meter. If he crosses 0.5 meter mark, the torque of man dominates and the system will collapse. The contact here will be lost. Okay. Prior to that, there are two contacts. Here also you will have a contact. Suppose in this case, suppose if X is less than 0.5 meter, then the free body diagram of the plank is like this. W man W plank and normal reaction. That's the situation. So if X is less than 0.5, the condition is N into 5 plus W man into X is equal to W plank into 2 meters. Remember, this is the condition if X is less than 0.5. You give me X, I'll give you N. If X is 0.5, N is lost. Because N becomes 0. Got the point? Are we clear here? Right. May I proceed for the next question? Do this. Do this, everyone in the class. Try to do this. A stick suspended with the 2 strings. A uniform stick of mass M and length L is suspended horizontally with the help of 2 vertical strings as shown. String 1 is tied to one end of the stick and string 2 is tied to at a distance L by 4 from the other. Find the tension in the two strings. Now you try to draw the free body diagram of the arrangement. This is a T1. This is a T2. And that is mg. Right. Remember, this is L by 4. This is also L by 4. And this is L by 2. You said that's an equilibrium. So sigma Fi 0 means T2 plus T1 is equal to mg. Equation 1. Right. It's an equilibrium. So therefore, tau about C. Yeah, I see. It is your choice. You can choose any point. No issues. But torque about C is 0. In this case, what is the sense of rotation of T2? It's in which sense? Clockwise sense. And this is in anti-clockwise sense. So therefore, T2 times L by 4 is T1 times L by 2. So therefore, T2 is 2T1. This is equation 2. You solve 1 and 2. Now, obviously, when you put 2 in 1, you will get 3T1 is equal to mg. So it implies T1 is equal to mg by 3. Therefore, T2 is 2mg by 3. That's all. Any doubts? I think I need to discuss one problem with you. Everyone try this. Very good question, actually. In a circus show, several clowns stand on wooden boards are arranged in a queue. Each board can rotate about a fixed. Yeah, read the question. Now try to do this. I've given sufficient information to handle this. Now in this, we will label this situation. Yeah, this is an infinite board actually. We will label this situation in the circus show, several clowns. Okay, fine. Length is in the ratio. If this is a 2 units, this is a 1 unit. And if mass of clone is 80 kg, that board is negligible and the load is 30 kg. Right. I will start like this. I am taking N1 as one of the normal reaction force for the first clone. This is the normal for the first one, normal reaction N1 on the left leg. Here you have the fulcrum. You said this is 30 kg. So 300 Newton. This is 2 units. This is 1 unit. So therefore, from this N1 left into 1 unit is equal to 300 into 2. So N1 left is equal to how much? 600 Newton. And whereas for the first clown, N1 left, N1 right, N1 left plus N1 right is weight. You got this as 600. The N1 right is equal to mg, 800. Therefore, N1 right is 200 newtons. Now again, I will do the same process repeatedly. Now you will have this one as N1 right and this one as N2 left. And this is again 2:1. N1 R already you know 200. 200 into 2 is N2 left times 1. So N2 left is 400 newtons. Therefore, N2 right will be 400 Newton. Why it is 400 Newton? Total is 800 Newton. Now you go for the next situation. Here is your fulcrum. Here is your N2R. Here is your N3L. This will be 2 and this will be 1, which means 400 into 2 is N3L into 1 implies N3L is equal to 800 newtons. Therefore, N3R is equal to 0. So you require 3 clowns totally. So we require how many? 3 clowns totally. Go through the entire question if you have any doubt. If you have any doubt, go through the entire question. Any student having doubt on this? Are we clear, Pakka? Sure? Huh? Right. In the same, both are Pathfinder questions. Not right. A balance consists of a straight line, right? Straight line rod, a right angled, okay, 4 loads, fine. See, what I would like to see is, according to me, this diagram according to me is one single rod. ఇలా రాశాను డౌటా మీకు? డిస్టెన్స్ లేదు కదా, ఇక్కడ ఉంది కదా ఇండికేషన్ ఇక్కడ. సి ట్రై టు ప్లీజ్ అండర్స్టాండ్ 1 యూనిట్. యు టేక్ 1 యూనిట్, 1 యూనిట్, again 1 unit, again 1 unit, 1 unit, 1 unit. ఇప్పుడు లెఫ్ట్ సైడ్ టార్క్స్ ఏమవుతుంది? అబౌట్ ఫల్క్రమ్. ఎంజీ టైమ్స్ ఎన్నున్నారా? 1 2 3 ప్లస్ 3mg టైమ్స్ 1, okay, is equal to mcg times 3 plus mg times అరే నాన్న ఇక్కడ 6 mg, ఇది 4 mg. So mcg into 3 is 2 mg. So therefore mc is 2/3 times mc. 2/3 times m. అంతేనా? ఓకే, ఎనీ డౌట్? m ఏదో వేసుకోండి అబ్బా మీరు. దట్స్ ఆల్, డన్. ఎనీ డౌట్స్? Please try to understand questions of this category. They are of really easy actually, but only depends on your ability to solve. I didn't posted all these things initially. ఎందుకంటే ఇప్పుడు అది టీచర్లకు ఇస్తున్నాను నేను, క్వశ్చన్స్ సొల్యూషన్స్ పెట్టిస్తాను. ఇవి వాళ్ళు you see this question. Load A of unknown mass is suspended at one end of a rod of length L. And another load B, you can see that mass 30 kg at the other end of the rod stays horizontal, provided the rod is pivoted at L/P away from its center O. See, at center O. That's very clearly mentioned here. Right. First part of the question. Let us adhere to the first part of the question. From the first part of the question, I can have mg mag mbg. First part of the question. For the first part of the question, I have mag into L plus L/P. Agreed? Hello? Remember that this distance is L plus L/P. L L/2, L/2, because L/2, right? Plus mg times L/P. ఇదంతా clockwise కాదు, anti-clockwise torques. All these are anti-clockwise torques. This is equal to the only mbg into L/2 minus L/P. Equation 1. I hope you are very clear on this. Next. Any doubt? Sushmita, Pakka. నువ్వు అక్షిత కాదు, రక్షిత. Right. Next. See, in this, what is the equation? You have only one weight torque here, mg. So mg times L/Q is mbg times L/2 minus L/Q. Equation 2. You have two equations. Use these two equations. By using these two equations are your only thing that you need to eliminate. What you don't require is mbg. What you don't require is a mg actually. You can eliminate this mg term. So you use mgl term here. By solving this, అసలు ఫస్ట్ ఆఫ్ ఆల్ రెండు ఉన్నాయి. అసలు మీరు ఏది కూడా ఇలా పెట్టుకోవద్దు, ఎవరి ద్వారా స్టార్ట్ చేసేసుకోండి. ఒకసారి అలా భయ్యతో మాట్లాడి చేసుకోండి. రావాలి అనే కంపల్షన్ ఏం పెట్టుకోవద్దు. అవును లేదు, లేదు, ఒకళ్ళు అక్కడ ఒకళ్ళు ఇక్కడ చేసేయచ్చు. ఒకసారి మాట్లాడి కన్ఫర్మ్ చేద్దాం. రైట్ 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 ఓకే రైట్. Now you can see here. Now you can see here, by equation 1, equation 2, just solve these two equations. Only thing that they don't want is MGL by Qter. By solving these two using equation 1, equation 2, you can get a relation MB is equal to MA time. And we have done this question earlier by P plus Q. That's what you will get. They are given the terms for P and Q. Find the mass of load A. They have given, I think, the mass of load P. That's all. Any doubts? It is also a simple question, actually. Right. Just stop here.